So like I said, we're looking at graphing rational functions. So the first part of it just says that a rational function is going to be in this kind of form. So P of x is always going to be the top, or the numerator. Q of x is going to be the bottom. Just goes alphabetical. And it says that P of x and Q of x are polynomials. That just means it can be x squared, it can just be x, it can be anything like that. It tells us that the domain of the rational function is going to consist of x values for which the denominator is not 0. So our domain is the values that do not make the denominator 0. Okay? So in this case, 1 makes that denominator 0. So our domain is going to be everything except for 1. Okay? That's a concept you already knew. The asymptotes that a graph can have are 3 types. Vertical, which we've talked about. Horizontal, which we've talked about. In fact, this one would have a horizontal asymptote of what? Y equals 1. Make sure you say y equals. You have an online quiz for Big Ideas that's due on Monday. And if you don't put y equals, they count it wrong every time. Some people in the other class were kind of upset about that. But I'm giving you guys fair warning to make sure you use the x equals and the y equals. The other type of asymptote we're going to talk about tomorrow is a slant asymptote, but we're not going to worry about those today. So the definition of a horizontal asymptote is a line to which the graph becomes close to as x goes to infinity and negative infinity. So back up here on this function, if I were graphing this, I'd have that vertical asymptote at 1. I would also have that horizontal asymptote at y equals 1. Sometimes the graph can cross the horizontal asymptote. And this is something that I'm going to want you to be able to find. Does this graph cross the horizontal asymptote? Well, what is the value of this horizontal asymptote again? Y equals 1. So I'm going to set this equal to 1. I'm just going to do it up here. I'm going to take that function, set it equal to 1. Now I'm going to cross multiply. So x minus 1 equals x plus 2. If I can solve this for an x value and get an answer, then that means yes, it's going to cross the horizontal asymptote. It will never cross the vertical asymptote. But sometimes it does cross the horizontal asymptote. That's a new concept. But if I try to solve this by subtracting x, I'm going to get negative 1 equals 2. Is that even something I can solve? No. So therefore, this is not going to cross the horizontal asymptote. So it's going to look like this. And therefore, my range in this problem is going to be from negative infinity to 1, union 1 to infinity. We would not include 1 in our range. But if that function did cross that horizontal asymptote and come back up, then 1 would be included in our range. And I'll show you some more examples of that because I know that's something that's new. But again, the definition for a horizontal asymptote is just the line that we get close to as x goes to infinity or negative infinity. So even if it does cross it, it's still going to get really close to it as it goes down this way. Sydney?
So if it does cross it, it's the range.
Yes, correct. All right, so now let's look at some guidelines for asymptotes. If we have this function and where p of x have no common factors, then all of this happens. But if they do have a common factor, this is important, this is a new concept as well, the graph will have a hole at that point. It will no longer be a vertical asymptote. That's like that problem that we did in our warm-ups, number 2 in our warm-ups. Remember how I said that problem that we had, which was x squared plus 4x plus 4, and we had over x squared minus 4, and that became x plus 2 times x plus 2 over x plus 2, x minus 2. And remember how these canceled? So therefore, negative 2 is not a vertical asymptote. What's the vertical asymptote only going to be? 2, positive 2. X equals positive 2 is the only vertical asymptote. So for this problem, there would be a vertical asymptote at x equals 2, and there would be a hole at negative 2. and then I would plug it into here. So what's negative 2 plus 2? 0. And then negative 2 minus 2, I don't care. It's 0 over negative 4, but that's just 0. So there would be a hole in the graph in this case at negative 2, 0. Okay? It is not always going to be a 0 here, though. It could be anything that we get when we plug in that negative 2 into here. So another new concept is that we can get a hole in the graph if anything matches. The graph of a rational function has a vertical asymptote at each real zero of q of x. That's a new way of saying it. All that's saying is whatever makes the bottom equal 0 is a vertical asymptote. We used to think of this as a shift to the right one, but now we're going to think of it as what makes that 0. A graph will never cross its vertical asymptote. The graph of a rational function has at most one horizontal asymptote. A graph can cross the horizontal asymptote. That can happen. Okay, now here's some important rules for horizontal asymptotes. If the degree of the top, p of x is the top, is less than the degree of the bottom, so if the top power is less than the bottom power, then y equals 0 is a horizontal asymptote. So let me show you an example. Y equals, I'm going to make the top power less than the bottom power. See what I've got there? This degree is what? X to the first, the degree is just 1. What's the degree here? 2. So 1 is less than 2, so this would have a horizontal asymptote of y equals 0. That's a new concept too. Degree on the bottom's higher, y equals 0. If the degree of the top is equal to the degree on the bottom, we talked about this earlier, then the line y equals a over b is a horizontal asymptote, where a is the leading coefficient of the top and b is the leading coefficient of the bottom. So if I wanted to change this, if I make these equal now where would the horizontal asymptote be? The powers are the same, so we divide by these coefficients. 1, y equals 1. Okay? All right. The last part we're going to deal with tomorrow. If the degree of p of x is greater than the degree of q of x, then we have no horizontal asymptote, and we're going to have a slant asymptote. Slant asymptotes are kind of weird looking. Let me show you where we would have a slant asymptote. When the power on the top is less, whoopsie, didn't put that in right. Power on the top is less than that power on the bottom. I'm just putting anything in here. I have no idea what this will look like, but hopefully we'll see the slant asymptote. All right, that does have a slant asymptote. The slant asymptote is going like this. It's an asymptote that it's approaching. Okay. All right, so now let's come down here. One more thing though, to find x-intercepts, we plug in 0 for y and solve for x. To find y-intercepts, we plug in 0 for x and solve for y. That shouldn't be anything new. Let's look at example A. Find the asymptote. Look at the powers. The degree here is 1, the degree is here 2. Anybody know what the horizontal asymptote would be? Y equals 0, good. And now go ahead and find the vertical asymptotes. You have to factor the denominator to find the vertical asymptotes. You should get x equals 2 and x equals negative 2. You get that? Okay. All right, number 2, very similar problem. But now we have x squared and x squared. So now the degrees are the same. So what's the horizontal asymptote going to be now? Right, and I can't just put 3. I have to put what? Y equals 3. Good. And then to find my vertical asymptotes, I have to factor that denominator. So I have to put x and x. What are numbers that multiply to be 4 and subtract to be 3? Dominic? Right, so I'm going to have to use a 4 and a 1, a plus and a minus. Charlie, can you tell me what the vertical asymptotes would be then? What makes that be 0? Right? Good. And so those would be our vertical asymptotes. All right, this one, you can see how these two look very similar. These two look alike though. I meant to change this one. So let's go with something a little bit different. So let's say now we've got 3x minus 3 on top, and we keep this denominator the same. Before you can find your asymptotes, what did I say you need to do? Factor. So we already know how the bottom factors, x plus 4 and x minus 1. You might be thinking, yeah, vertical asymptotes at -4 and 1. Again, wrong. Let me show you this in the calculator. I want you to see that we do not have 2 vertical asymptotes here. And I want you guys to see if you can think about why we don't. So when I graph this, here's the way it looks. We don't have 2 vertical asymptotes. We only have 1 vertical asymptote at -4. Why isn't there a vertical asymptote at x equals 1? Michaela?
When you factor out 3 at the top, it'll be 3 and then x minus 1, so it'll be a whole lot.
Right, these two cancel. So when that happens, like we said a minute ago, that means that we're going to have our vertical asymptote is still at x equals -4, and we're going to have, what's the horizontal asymptote? Look at the powers. Not that, this. Look at the powers. What's the horizontal? Y equals 0. And then we do not have a vertical asymptote here. We have a whole at 1, and now I plug 1 into what's left over, 3/5 at 1/3. So that's all the information there. Now look at how that's going to work. If I look at my table of values, it's going to show me that when x is -4, oops, going the wrong way. When x is -4, that's telling me I have a vertical asymptote because there's an error there. But when x equals 1, there's also an error. But it's not because there's a vertical asymptote. Why is it? It's because there is a hole in the graph there. So it's a discontinuity. All right, let's get really tough now. Let's talk about the domain and range of this. Let's go ahead and do domain and range for this one. Yeah. I plugged in 1 back into this part of the function, so I have 3 on the top. 1 plus 4 is 5, so it's 3/5. Okay. Anybody else questions? So now think about the domain. The domain means all the x's that do have answers. Look at the table again. All of the x's that do have answers. If we don't have an answer, if we have error, if we have a hole, or if we have a vertical asymptote, it is not in our domain. Anybody want to try it, the domain? Abigail?
Is it negative -1? Negative 1.
Well, where are you getting -1?
I'm 1.
Okay, -4 to 1, good. And then what?
1.
You got it. Excellent. She's right. We can't use -4 and we can't use 1, so that's going to be our domain. All right, now let's think about our range. Range is even tougher on this one. Charlie?
Negative infinity to 0, 0 to this.
Nice job. Yes. All right, good job, guys, with that domain and range. That's tough. All right, excellent. That's a good sign. Let's flip over to the back. So now we're going to try to figure out everything for these functions. We're going to graph. We're going to find all this important information. So first of all, identify all of our asymptotes. Let's start with the verticals. Factor first. That part's pretty easy. That's x equals 2, x equals negative 2. Horizontal asymptote. I have to check, does it cancel? No, it doesn't. So now I'm just going to look at degrees. What is it, Maya? What's the horizontal asymptote? Good. Y equals 0. Okay, so we got that. Let's go ahead and graph as we go. So I'm going to put in my vertical asymptotes. Okay, so let's see what else. Domain. Am I ready to give the domain a shot? You should know it, guys. We only have 2 values we can't use for our domain. Go ahead, Charlie.
Negative infinity to negative 2, and then negative 2 to
What'd you say, negative 2?
2 to 0.
Okay, good. And then what? Right. Good job. All right, we'll wait a minute for our range. Let's kind of go ahead and graph. Now, the good news is on your next quiz, you are going to be allowed to use a graphing calculator. We don't want to be dependent on it, but some of these just take so long to test values. Actually, this isn't too tough. I'm just going to find values without using the calculator. So if I want to find a y-intercept, I'm going to plug in 0 for x. If I plug in 0 for x, that's gone and that's gone, so I'm just going to get negative 3/4. That's going to be a y-intercept because x is 0. If I want to find my x-intercept, I'm going to plug in 0 for y. So if I plug in 0 for y, and then I cross multiply, I'm going to get x plus 3 equals 0, and so x is going to equal negative 3. That's going to be my x-intercept. Those points just allow me to kind of know what's going on with the graph. So at 0, I'm going to be at negative 3/4. I'm going to be at negative 3, 0. Now, that's an important point, that negative 3, 0. Because it lies on the horizontal asymptote, your questions are also going to say, if the function crosses its horizontal asymptote, state where that occurs. Can you see that this x-intercept is crossing a horizontal asymptote? So therefore, I would say crosses HA at negative 3, 0. That's another important piece of information. Now, if I wanted to figure out what this whole graph looked like, yeah, Charlie?
Can you explain that a little bit more?
I will. So because my horizontal asymptote was at 0, and this y value is 0. See how this says y equals 0 and this is y equals 0 here? So that's telling me I have a point when y equals 0. This is my horizontal asymptote, and see how that point happened to fall right on it? So therefore, we're going to cross that horizontal asymptote. Look at the graph and I think it'll make more sense. I just graphed it. So what's happening is if I hit trace, let me zoom in a little bit here. Negative 5, 5. I just want you to be able to see what's going on here. So here, can you see how it's crossing? Like, remember how we said vertical asymptotes, it never crosses? But in this case, it happens to be crossing there. If I hit trace, I'm going to go way down over there and you'll see how this works. Go down. Okay, so see right there? See how my y value is positive, but then as I arrow down, see how now that y value is going to be negative? Eventually, there. See how it switched from being a positive y to a negative y? Right there, it's crossing that horizontal asymptote. But then, if I were to sit here and hold this down forever, eventually it's going to come back up and try to get close to that asymptote, but it's never going to touch it. It's just going to get infinitely close to it, yeah.
So does it like actually have a point in front of the asymptote?
Yes.
Isn't that what makes it asymptote?
But that's what I want you to understand, is that you can cross a horizontal, you just cannot cross a vertical. Okay, so horizontal asymptotes, it just means it's going to come down like this, cross it, and then come back up like that. See, it always stays really super close to it, but it can cross it. Now let me do a zoom 6 so we can just see the rest of this. So the rest of our graph I can see. Looks like this. And this one, it's not going to cross. And the way I know it's not going to cross is because the only place it crosses is at -3. So I know it can't cross down here. So that's the way it's going to look. On your next quiz, we're going to be super picky about things because we're letting you use your graphing calculator. So if you had just done this real quick and put this up here and didn't show that it crossed, we would take off a point for that. Because you can look at it and see even that it does cross. Okay? Now let's do our range. Now you would think that would make the range easier. Ooh. But it doesn't. This one actually, the range is going to be really tough. Does anybody know why the range is really tough on this one? Yeah, Cindy? Yeah, it's because it's crossing right there, and this point is not going up to 0, I don't think. Watch what I'm going to do. I'm going to find the maximum. Oops. I want to find the maximum right in this little region. So this goes up to -0.65, but I don't think this one goes down to -0.65. This is actually a very tough problem to write the range for. This range would be like -infinity to -0.65 union, and then I would have to see how low it goes right here. So I'd have to do second calculate a minimum. And I would have to see, like I said, how low this goes. So I'm going to come over here quite a ways out, and then I'm going to go over this way. And so that's the lowest that it goes, 0.095. You guys will never have one that difficult, but it's kind of good that you saw that. Do you understand there? See how we have this little gap in the values of y that we're allowed to use? And that's why I had to exclude those, and I had to go through a lot of work just to find that. But yours aren't going to happen like that. Yours are going to mostly be continuous in there. Okay, let's do one more here. We're going to save 3 and 4 for Friday. Okay, so first thing we do, factor the denominator. Baxter, how's that denominator factor?
It'll be x plus, or x minus 1, x plus 1.
We need numbers that multiply to be 2.
Oh yeah, sorry, x minus 2, x plus 1.
Okay. There we go. All right, now we also want to factor the numerator because we got to see if anything's going to cancel out here. Natalia, how's the numerator factor?
Factor the formula.
Be x plus 1, right? So is -1 going to be a vertical asymptote? Yes or no? No, it's not, is it? Because it cancels out. So my only vertical asymptote is going to be at x equals 2. Let's go ahead and put that in there. Okay, horizontal asymptote, the power's higher on the bottom, so it's going to be what? Y equals 0. Okay, let's go ahead, find, you can do these things in any order. I'm just going to go ahead and find my intercepts. I'm going to plug in 0 for x. If I plug in 0 for x, I'm going to get -2 for y. Just plugging it in either place, really. I get 0, -2. Going to see if I have a y-intercept, so I'm going to take this simplified function and I'm going to set it equal to 0. If I cross multiply, I get 4 equals 0. So what does that tell me? Can 4 ever equal 0? So I have no x-intercept. Right there, that tells me no x-intercept. All right, so I have no x-intercept. I've got that. I could test some points now, or I could go to the calculator. But see, if I know I don't have any x-intercepts, I know this part of the graph already. Because I know it's not going to cross it, right? It's not going to cross it anymore. Plus, if I just asked you to graph 4 over x minus 2, you would know how to graph that, wouldn't you? It would just look like this and like this. But here's something we have to put in here, is we have a hole at -1, and then I have to plug back into this factored function. So what do I get if I put -1 into 4 over x minus 2? What's 4 divided by -3? -4/3, right? So at -1, -4/3, right here, I need to show that hole in the graph by doing that. That shows me that there's a hole in the graph there. I know this part over here, I'm just going to test 1 point just to see. I'll test 3. If I plug in 3, 4 over 1 is going to be 4. I just wanted to have at least 1 point over here to get kind of some idea of what this is going to look like. Looks like that. Okay, and now you guys try to write down. We've got, let me just jot this down. We have x-intercept is none. The y-intercept was 0, -2. Is it going to cross the asymptote? No, it's not. Remember how it never could equal 0 for y? So it does not cross. And domain and range is it. See if you can write the domain and range. Caroline, you got the domain? Yeah. Good. Awesome. Good job. Okay, what about the range? Who's got the range? Natalia?
-infinity to -4/3, and then union 4/3 to 0, and union 0.
Awesome. All right, guys. Excellent work. So you can see this is a lot more challenging than what we've been doing, isn't it? But that's all right. It's good to have